Dear students, from today we are going to start another series of modules on software engineering. So you might have listened about mechanical engineering, civil engineering and electrical engineering and other engineering sciences. So all of those sciences have some focus to build. For example, electrical engineering try to invent and do research and practical work on devices, on electrical devices. Similarly, mechanical devices is researched and practiced in mechanical engineering, and similarly building control and buildings construction and similar kind of things are achieved in civil engineering. So in software engineering, we want to build softwares which can be used by the humans with a proper satisfaction level. So let's have a scenario. For example, you have been given a task of constructing a commercial building having 5 floors and the size is 50 feet by 90 feet, which is one canal. So you are going to make one canal commercial building having 5 floors. So what do you think, what will come in your mind when you are given such a project, or anyone who is expert, even if someone is expert, then what are the questions he or she need to answer? So let's have a look on them. So for example, first question would be, how can you estimate the cost in time, money and other resources to complete the project? So similar question will be asked from a software engineering firm or software engineer who want to engineer the particular software. So you need to estimate the cost, and that cost and time and resources are not the generalized one. So for example, if you have done 100 projects, so you cannot simply apply the knowledge of the 100 projects and you can say, okay, roughly on average I used to have 1 year to complete the project, so I estimate that I will need 1 year for this project as well, which is now being offered to you. So this may take more than 1 year or it may take less than 1 year. So similarly, the next question would be, how can you divide the project into manageable pieces? So whether it's a software, whether it's a building, so you need to make small pieces of that particular project. So you cannot start all of the things all together. And then the next thing is, how can you ensure that the pieces produced are compatible? So you make smaller modules of the software and then you try to integrate those modules with one another. So they should be compatible enough. So similarly, as for our scenario is concerned, if you are trying to make window in a building, so you have given a scale that the length and width of the window would be so much, and then you have given the order. So if the aluminium guy comes with a different size, then that window is not compatible with the size you have already in your house or in your building. So similarly, in softwares, if you have built a module without understanding that how this module will interact with other modules to make the overall software, so you are going in the wrong direction. So you should concentrate on this aspect as well. And then how can these working on various pieces communicate? The people who are working on different pieces, they want to communicate with each other, and what would be the procedure, and were there be any special protocol for discussion? Will that discussion be saved somewhere and then that can be tracked? Similar kind of things. And then how can you measure the progress? Whether one of the module is being developed rightly, wrongly, the time estimates are going beyond the time limits, it is overrun in terms of time, cost, so you need to see. And how can you cope with the wide range of details? So if we have wrong estimations, this means that could lead to cost overrun, that could lead the delivery of products, and we could have the dissatisfied customers, and of course then next time those customers will not have project with us. So difference between software engineering and other engineering is that using off-the-shelf components. So for example, if you want to make a vehicle, so you are not going to make the engine for that vehicle from very scratch. So the engines are already available. For example, you belong to a company manufacturer of vehicles and you want to launch a new model. So normally in the new model you have the same many things as same as they were in the previous model, and in the next model you have just changed slight things. So you are using off the shelf things which are already available. So in software engineering, normally all projects or majority of the projects which were developed in the past, they had to build from scratch. So everyone was reinventing the wheel. And then there are some practices which says that you should not do it and you should also use off-the-shelf components. And then there is a phenomena known as computer-aided software engineering, and that has different case tools which helps on cost estimations, project scheduling, personal allocations, progress monitoring, writing and organizing the documentation, prototyping, interface designing, and writing and debugging code. So all of these things have been implemented in case tools which help you to make a standardized software product. And then there are some integrated software development environments which are called IDEs, and they have combined tools of editors where you write your code. For example, in the previous modules we have written our code in an editor, online editor of C++. And then we have compilers in those tools, and then debugging tools also in this integrated environments. So if we summarize today's module, we have learned software engineering discipline with a scenario, and we have compared it with other engineering sciences and how estimations can be done and what are the impact of wrong estimations. And we have seen case, computer-aided software engineering and case tools and integrated development environments.